So what we're going to be talking about is, really the reason for using PyTest, and then how you can step by step build a solution using PyTest, and also use it to do things like set up continuous integration. So before I get into that, though, let me just get a quick pulse check here about everybody's experience. Let me just push this here. Everybody's experience with GitHub Actions. So give you a little bit of a time here to answer that poll question. And hopefully everybody has been able to see this GitHub Actions poll. Let's see if you've got that. There we go. All right. And it looks like a pretty good amount of people that have responded to it. So we can probably go from here. All right. So it looks like we have a lot of beginners with GitHub Actions, some beginners, a little bit of intermediate. Yeah, so this is going to be one of the things that we're going to tackle is GitHub Actions. That's good to know. So let me just kind of get right into it and share my screen here. And I'm going to go here and go to this. And we'll go here. So one of the things I think that's interesting about testing is that sometimes it can be confusing when you want to figure out, like, well, what's what problem are we solving here, and why am I testing, and additionally, what's the methodology, right? Like what's the framework step by step. And to start with here, let me just maybe whiteboard out the whole process from beginning to end. So in terms of testing, I would say that you need to think about this concept of testing. There we go. Of the DevOps lifecycle. So in terms of DevOps here, lifecycle. So if we go and we think about what that is, a lot of times it's really about automating things. So we have here we have automate, and then we have the check-in process as well. Check-in, automate. And basically you would test your code, and we will lint our code, and also verify that it can be deployed. And so that's these are some of the concepts that happen in a real world project. Is, let's say you're working as a DevOps engineer, or you're working as a web developer, or you're working, in some other kind of software engineering ecosystem. The idea here is that you want to be able to always have your code in a known good state, and that's part of this DevOps lifecycle: is test your code, lint your code, deploy your code. And what we're going to do is we're going to start from the very beginning and build this out. Like, let's say it's your first day on the job. So, the first thing I would do is make sure that I had a cloud-based development environment. So it doesn't really matter which one we use. In this case, we'll use, let's say, Cloud9, which is from AWS. And in terms of AWS, we will first create a Makefile. Next, I'll create some kind of a source code file. I'll make like let's say a hello.py file or something like this to just kind of get things running. Next up, I will do a test file. So we'll say like test hello.py, and then we'll also do a build process. So we'll go through here and we'll do a build process. And the reason for doing all this stuff and creating this scaffolding is so that you have a repeat process, right? So you have a repeatable process to check in your code, to test your code, to you always know that the packages will be installed in a certain way. So I call this the scaffolding process. And if you follow these steps, which I'm going to go through in a second, you'll have the best outcome. You'll have the best ability to have success in your project. And then once you do that, then the next step, and this goes to the GitHub Actions question, is let me just whiteboard this out, is that you'll then have this automated feedback loop that protects you against problems. So the first part would be you have, let's say, GitHub here. There we go. And then from GitHub, you will access some kind of an event. So the event could be, the code has been checked into the repo. The next thing that would happen is that you would trigger a GitHub Actions, and this GitHub Actions would do whatever you told it to do. Oftentimes, this would be where all the stuff that Alfredo just went over, we would go through here and do PyTest, right? Or we would maybe format our code, or we could also, go through and lint our code. And what's great about this is that every single time I make a change, this is happening. So it's actually another word for this is Kaizen. And what Kaizen does is it will allow people to do continuously improve their workflow. So we'll call this CI. So continuous improvement of what they're building every single time they touch a file. So they will check in a command line tool and they make a new flag. Immediately GitHub checks it, goes through, lints it, tests it, and once you've got this set up, and this is called the CI pipeline, this continuous integration pipeline, then the follow-up step would be, well, I got that working. Why don't we do continuous delivery, right? And so the next step there would be that we could go through and deploy the code automatically. And so in this case, this would be, let's say it was a web application, we would go through and deploy that web component. So that's really the main takeaway of why you would want to use testing and linting, is that a lot of times it's easy to get caught up in, just maybe you're only testing because someone else told you to test, or, I guess we're supposed to test, so I'll write some tests. But the bigger picture is that what you want to happen is every single time you make a change, you actually want things to get better, not worse. And there's an expression, are you getting better or are you getting worse? And if you don't know which one, you're most likely getting worse, right? And so in this particular situation, this is what we're doing. We're making things better by building up automation. So let's do that. So let's go ahead and step by step build a project, piece by piece, build this automation together, and then also build through a GitHub Actions workflow. And then ultimately, we also can look into how continuous delivery would work as well. Okay, so first step here is that I'm going to go to console, and I'm going to go to my AWS console account here. And we'll log in. Okay, so the first thing that I would do when I'm creating a cloud-based environment is use one of these cloud-based shells. So AWS has Cloud9, Google has Google Cloud Shell, and Azure has Azure Cloud Shell. In this particular case, again, we're going to use Cloud9. So we'll go through here and pick Cloud9. Now the idea here is that I'm going to create a new environment that will be the place that where I host my source code. So in this particular environment, this is going to be called Devops PyTest. And I'll put a description. This will be a project where I build code systematically, step by step. There we go. And from here, you can see there's create a new EC2 instance from an environment. Here's a micro instance, and just a little bit of a item here to bring up is that in this particular environment, I'm going to have it launch a virtual machine for me, and then I'm going to use a free tier virtual machine. Now the idea here is that you could use larger machines, and in fact, one of the things that's interesting about the larger machines is that you actually can get these really powerful machines. But if you're going to just build out like a scripting environment where you're building command line tools, the free tier account is totally fine. And again, other clouds as well, totally fine. So I'm going to use the defaults as well. So Amazon Linux, one of the things I like about Amazon Linux is that that's the operating system that AWS will use for most of their examples. And so you'll have a pretty good experience if you stick with the defaults. I think that's one takeaway with the cloud environment is in general, it's not a great idea to start tinkering around with the operating system too much or, the packages that are installed, because a lot of times there's a reason they're configured that way, and it'll just make things a little too complex. Also, this is going to time out after 30 minutes, which is great because it'll save me a bunch of money. So first step here, what I'm going to do is I'm going to create this Cloud9 environment. And this takes usually like 60 seconds or so. And then while that's actually being created, the other thing that I will do is open up GitHub, and I'll also create a new repo just for this particular project. So I'll go here and I'll say Devops PyTest and call this is a repo that will do Devops actions. Here we go. Perfect. Okay, so we've got this repo. It's set up to basically have a default here of a README, a get ignore. That's really the base, a good baseline here. Now that that's set up, I can go back to this Cloud9 environment and just if you're not familiar with Cloud9, I'll kick the tires a little bit here. So in a nutshell, what Cloud9 does is it provides a version of Python for you. So if I type in Python 3, right, it installs Python 3.6 for me. It also has AWS command line tools. So if I just type in AWS S3 LS, for example, it'll list all the buckets that I have in my account, right? So these are all good examples of like the integrations that you get, and that's why I prefer to use the cloud-based development environments. Is oftentimes I'm building something for the cloud, so it's going to be a better workflow. So once I've got this set up, the next thing that I will do is I will clone this repo, right? So go to this code icon here, go ahead and click this. There we go. And if I type in git clone, we'll go like this. There we go. And then I'll go through and say yes. Now notice how it has a failure point there, right? So what's an issue about this failure point is that I'm going to have to create an SSH key to do bidirectional communication between these two machines. So let's go ahead and do that. Let's type in SSH keygen -t RSA. And what this does is creates a public key and a private key. And I'm going to take the public key and I'm going to put this into GitHub. So first here, I'll go through here and cat out what that public key is. So go through here and do this. And from here, we'll go through and print this out. There we go. Now, if I go back to my GitHub account, I can go to my icon profile, go to settings, and just paste this into the SSH and GPG keys. The reason you do this initially is that then you don't have to type in a password, and it solves a lot of problems with authentication. Okay, once we do this, then we're good to go. We have this environment set up here, and I can do the up arrow and go back to where I was before. So let's go through here and let's do git clone. There you go, perfect. Great. Now, inside of the Devops PyTest directory, there's not anything in there, right? So it's a complete empty project. And so this is the part where you would start building out the scaffolding. And this is the approach that I use, and I would recommend it to people. So let's go through here and do these steps, step by step. So first, we'll go through here and we'll say Python 3 -m venv. So create a virtual environment ~/dot, and then I'm going to create a virtual environment called what the repo is called. I like to do that so it's easy to remember what I created. So Devops PyTest, there we go. And once I create this virtual environment, I'll then source it. There we go, bin activate. Now, the reason for doing this, and I think Alfredo got into this as well, is that it really just eliminates some of the things that can go wrong in a Python project. It's possible to do this without using a virtual environment, but because it isolates your Python here, it makes testing go a lot smoother. So got this initial setup here. Now, what I typically do next is that I will then touch file. So what a touch does is it makes an empty file. So first, I'll go through here and I'll cd into this repo, and then I'll touch a Makefile like this. I'll also touch a requirements file, and then I'll also go through and create an empty source code file. So we'll just say touch hello like this, and I'll also create an empty test file. So go through here and I'll say test hello.py. So we basically have these 4 files here: Makefile, requirements file, hello file, and a test file. And what do they each do? So the Makefile, all it is a way to run commands that have a bunch of syntax flags and things like that, and put them into a stanza so that you can run them over and over again without having to remember all that stuff. That's really, it's like a shortcut. And then the requirements file will list all the packages in our project, and then the hello file will be the source code, and then the test file will be the test of that source code project. So let's first start to build out the things in the Makefile that I would need. So typically what I would do in a requirements file project is double click this and it opens up the editor, and I would put in PyLint. That's most projects. I would use PyLint. I would use PyTest, and I would use PyTest coverage, which is a coverage report for PyTest. I would also use Click, and I think this is a good start, just like this. Now, how do I install that and use that? Well, this is where in the Makefile, if I double click on it, I can put in that install command. Now, one thing to remember about in these cloud editors, they're still developing, they're getting kind of up to speed, is that if you click on this, we go to spaces. The idea here is if I click on the spaces, I need to go to tabs and make it tabs. And so what the tabs section will do is that it will make sure that when I go through and I indent things, that I'm not indenting with a space, which a Makefile will have a problem reading. So it's really more of like a one-off thing you need to do the first time you create a file, is make sure that the Makefile, in whatever environment you're in, if it's Visual Studio Code, if it's a cloud editor, that you've got the Makefile set up to tabs. Once that's set up, then I can start to type in commands. So I can go through here and say install, right? And then what I would typically do is put in some install commands. So there's a couple ways to remember these commands. Because I've already done this previously, I'll just go to a repo I've set up where I have some of the stuff already, and I'll just copy some of it. So I'll just, and I'll show you what these commands do. So what this does here is that it goes through and does an upgrade of the Python packaging tool. So it's really common for Python pip tool, the PIP tool, to have an upgrade that's necessary. So I just upgrade it automatically when I first start a project. And then I say pip install -r requirements.txt. What that means is that go inside of the requirements file and let's make sure that you are installing these packages. And so this is really like a first step for any project. So let's go through and test this out. So I've got that running. If I go to this command, I can type in make install like that. And again, all this really does is just bootstrap my environment here to make sure that I'm able to actually install my software. And what's nice about this is that I can do this on any cloud environment. So, or I can do it on my local machine. Is once you use this format of first create a virtual environment, check out your source code, source the virtual environment, and then run a make install command, you know that you just have to do that in any location that you're at. And also build servers later that we'll get into do the same thing. So this is a great technique that is reproducible and that you would want to do every single time you work with a project. So the next thing that we'll do is go through and build out a little bit more in here. So what I'll do is I'll go to the hello file, and I like to do a really simple function. So functions in Python, in my opinion, are really where it's all where you should be focusing your time. And what I'm going to do here is I'm going to say def. I'm going to say let's call this Marco, and this Marco function will take a name, and I'm going to say if the name matches something, like in this case, if the name is equal to Marco, then I want you to return back the word polo, right? Otherwise, we'll return back no match, just like that. So what this does is it allows us to do something really, really simple, right? There's a function takes a variable. If the variable matches the word Marco, it returns back polo. Otherwise, it returns back no match. So to call this, all I need to do is print Marco and then put in the word Marco. And what this should do is print back Polo. So how do I run this? Well, fortunately, I've already got my environment set up here. I can just go through and say Python hello.py. There we go, and it returns back Polo. And if I changed it to another thing here, for example, if I just kind of copy this and put in the word Bob, for example, this will return back. No match. There we go. There we go. So no match, right? So it's just a couple lines of code. We put something in, we match it, return back. So the next thing that we'll do is that we will build out a test function to test the logic of this particular piece of code. So what I'll do is go to that test file here. And the way PyTest works, which Alfredo already got into, is that I can go through here and say from hello import Marco. There we go. And I can just say def test Marco like this. And all I have to do is do an assertion. And so we know that if I pass in the word Marco, it should return back Polo. So it's a pretty easy test to write. So if I type in if I type in assert Marco with the word Marco inside is equal to Polo, right? Because that's what it returns back. All right, so how would I test that? Well, here's where I would start to also use the Makefile again. So I would go back again to this Makefile, and I would add a test section. So let's go through here, and really, why are we doing this? Like, what's the point of doing a Makefile like this? Again, it's because we want to be lazy, like in a good way. We want to be efficient, and so the next thing that we're going to do is find like an example test here, and I'm going to throw this in there. So I'm going to go back to this environment and put this in. There we go. So I'm going to say python-m pytest. I'll put in --cov, and what this does is it will create a coverage report for the file that I actually created. So it'll basically show me the lines of code. And then in this case, I can just say, I want you to do a test. I want you to actually run it against this file, which is called test.hello. Right? Now, it's a little bit lengthy and like irritating. It's like, oh, I got to type in python-m pytest -vv. You don't want to do that every single time you want to write a test. And that's the whole point of a Makefile, is that you want to be lazy. And you want to make it easy for other people on your team as well. You like, for example, if you're telling somebody on your team how to run your project, you say, hey, look, do make install, do make test, right? Then it's really simple to explain to someone. Imagine that another scenario is, okay, so yeah, you do pip install --upgrade & pip install -r requirements.txt. You pin your repository files, and you do this, and then you run python-m pytest -v, --cov equals. I mean, someone's going to go, hey, just stop. I don't even know what you're talking about. What is this? You're telling me all this stuff that doesn't make sense. It's pretty simple though to say, check out my project, create a virtual environment, do make install, do make test, right? And that's exactly what we're going to do with the build server as well. So that's the point of a Makefile. So let's go through here and let's type in make test. There we go. So we've got 100% test coverage because it's a very simple function, and we're able to run that inside of our test project. So this is an awesome place to be. And what we will do here is go through and say git add, and I'll just add all this into our project. So git add star like this, git status, git commit, adding initial structure for project. Now, a couple things will happen that are just normal is when you first create a project, you'll go through and create this information. And here we go. We'll say no gift like that. And we'll go through here and say global user email. And the reason it's asking you for this is so that when you do commits in GitHub, that it can track you by your email address and your name. So it's basically like a unique identifier, which is useful because then you can look at Git stats, for example. I'm actually a huge fan of Git stats. Okay, so next we'll go through here and we'll write it out, and we will exit. There we go. So next up, we'll say git push. And now I'm going to push these files into GitHub. So if I go back to my GitHub environment here, we will be able to see in this Python Devops, what was it called again? It was called Devops PyTest. The way I always check my repo name is I type in git remote -v, and it will tell me, okay, yeah, Devops PyTest. Okay, so I'm going to go back here and type in Devops PyTest. Perfect. All right, so inside of this particular project, you'll notice that all these files are created. I was able to successfully check those in. So this is where now things start to get more interesting in that definitely is useful, right? Because I could, for example, check it out somewhere else and everything should go pretty smoothly. And that's actually one of the things I wanted to share with you is let me show you why that's important that I did the stuff that I did. So I'm going to go to another environment here. And well, let's just use Azure for now. It doesn't really matter which environment, but I'm going to use Azure. And I go to Azure and I go to the portal and go through here. And I'll go to my account, log in. And Azure has kind of a similar environment. I'm going to click this button here that says Open Cloud Shell. And the main takeaway is that you don't have to create an SSH key connection yet because of the fact that I've already done this previously. If it's you and you're doing this for the first time, you would have to create an SSH key. But because I've already created one, I can just do the same thing I did earlier. And again, just imagine like this is a coworker. And in this case, it happens to be a cloud, but imagine it's a coworker and you're telling them how to check out your project. Well, if you use the methodology I just went through, it's pretty straightforward. You go here, you first create a virtual environment, you first check out your project. So we'll do git clone. And we'll clone this repo. Great, I'm able to clone that repo. I'll maybe CD into it and go here. Now, I would create a virtual environment, name the same thing, but put it in my public home directory with a dot. So I'd type in Python 3-m virtual environment, and then do ~/.devops PyTest, right? So this is just a convention that I use so it's easy to remember which project I'm working on. Great. So again, this was all the coworker would need to do is what I just did. Check out the project, create a virtual environment. Now I source it, ~/.devops PyTest, bin activate. Now from here, I can do my magic, right? I just need to run 2 commands. The first command is I'm going to type in make install, and that installs everything I need for my project. The second thing that I'm going to do is that I'm going to run make test. And so once this is done, I'll be able to do a make test. There we go. to make test. Why is this important? Is because my code is always in a known good state if I have this kind of a process. And again, imagine the suffering that you would put a coworker under if they checked out your project and they were, had to actually do a whole bunch of hoops and all kinds of stuff versus just saying, make install. So and then a make test. And so this looks good. Everything looks perfect. And in fact, even if I run the code right as well, you can see the same thing happens. Great. Everything works. Well, that's pretty good. But one of the problems is that we don't have the intermediate steps. So let's take a break for a second and go back to the sketchpad here and just whiteboard out kind of what we have and what we need to create to make it even better. So we have some good stuff for sure, and it's very helpful. So we have let me just reconnect this thing. So we have a GitHub environment. Let's go through here. Here we go, GitHub. And we have created a checkout into the cloud, right? This is our AWS Cloud9. AWS Cloud9. And then next, what we'll do is we will create that scaffolding, right? And so the scaffolding, again, is a Makefile. It also is a requirements file. .txt. Additionally, it has the source code inside of there. In this case, it would be the hello file. And then we have the test file. So it's pretty good because, again, how simple it was to just do a command like, make install. We'll just call this make install, and then make test. But the problem is that it's not 100% automatic. It's close because I can just tell someone, a human, hey, go through, run make install, make test. What's better than that? What's better than a human being involved is we want the robot to be involved. So we want the automation to be involved. So how do we do that? Well, what we do is we go to GitHub Actions and we tell this robot to test our code. So that's the next thing that I'm going to do is I'm going to set up GitHub Actions here to actually go through and automate my code. And so what will happen is that every time I make any kind of a modification to GitHub, that it will trigger some actions. And fortunately for us, these actions will be really simple and very straightforward, right? They'll be, we'll go through and do an install, we'll do a test, we'll do a lint, and then every single time I make a change, it's a little bit like a robotic vacuum cleaner that you have. Is that every day I have a robot vacuum cleaner clean my house, and I just know my house will always be getting some level of cleanliness because of that automated process. Same thing, your code is always getting tested, it's always getting linted, whatever it is you want to build in there. So this is a very, very powerful concept, and it's called continuous integration. And why is it so important is that it really is kind of a no-brainer. There's no valid reason to not do this, especially for a language like Python, which doesn't have a compiler. It only improves things. So it's going to make every single thing you do better. It's non-controversial. It's just a helpful thing to do. So let's go through and let's do this next step here. So what I'm going to do is I'm going to go to the PyTest environment here, and I don't need to do anything inside of Cloud9 to get GitHub Actions working. What I do though is go to GitHub. So I'm going to go to GitHub, and I'll make this a little bit bigger so you can see this. And what we'll do is select this icon Actions. And when I select Action, it will give me the ability to run any kind of code I want or any kind of action. Now let's take a look at some of the things you can do with GitHub Actions. So for example, let's say you're an open source Python developer. You could create a GitHub Actions flow that would allow you to install software, upgrade it. You could also and put it into the open source repo. You could also build, let's say, full Python applications. You could build web apps. You could also deploy your code to services like Azure, AWS, Google Cloud. And so this would be where the continuous delivery component would go in. So for example, let's say that you wanted to deploy to a container to Amazon ECS. So what that would mean is that you could containerize your application. Maybe it's a command line tool that has something to do with AWS APIs. You containerize that, it builds it automatically and pushes it to Amazon for you. So that is a really awesome integration because it's something that now another human doesn't have to do. Not only does your code get tested, but the human doesn't have to deploy the code. And typically, as I mentioned before, that's when the problems start, is when you have a human pushing buttons, testing something, or human pushing buttons to do anything. It's really easy to make a mistake. But if it's all happening automatically where the code is tested and deployed, then that's where you get the most powerful workflow, is the automation workflow. So the next thing that we're going to do is that we're going to enable this for this repo. So again, I'll go to a workflow that I create by myself. So I'll just go ahead and go here and just say main.yaml. And let's just look at a few of the different things here that are important. So this is just kind of a basic workflow here. Is the first step is we call it something. We call this workflow CI in this particular example. And we notice that this is when the actions will run. So you could trigger a different action on different branches. You could have a push action, a pull action. This also shows you let me make this a little bit bigger. This also shows you the operating system. So in this case, this would run on Ubuntu. And then you just put your series of actions, right? These are the automation steps that you want to do. You want to do linting, testing, formatting, whatever it is you need to do, you put those in. Now this one's a good one to start with because it's a hello world. And so what this one does is it literally types in hello world. And then the next one says, here's like a multi-line script. So let's maybe tweak this a little bit and say, hello Devops. We'll do this and just say add another action, test and deploy your project. And maybe even what we can do is just like list the content. So I'm just going to put a shell command at the bottom and just say, and maybe I'll even put an echo. I'll put echo listing output below, right? There we go. And let's go ahead and click this just to go start commit. We can say, creating hello world GitHub Actions. There we go. We commit this and push it in. Okay, that looks like it's good to go. Now, to see it running, I would just click on this icon here, and then you can see that it's actually triggered. There we go. So it's queued up. There we go, in progress. And from here, we can actually go through and run a setup job. And here we go. Here's first step, hello DevOps. Second one is add another action, listing output below. Right, so I can put anything I want in there. It doesn't have to be. It's literally any command. It's a shell. It's just a container that I have total control over. Now, what we also can do is if you go to this icon here, I'm sorry, if you go back to the main section and you go to this triple dot icon, you can say create status badge. And I think this is always a good idea, is to have the status of your build inside of your README file so that other people know what's happening. So I'm going to go ahead and I'm going to copy this. And from here, we can go through and kind of put this in here. So I'll go through here and do this. There we go. And we'll go through and get this running. All right. So the in this particular example, we now have GitHub Actions set up. We've got a status badge hooked up. So we're in pretty good shape, but it's not doing anything. It's just printing out those blank, commands. So it would be much better to clean it up a little bit and make it do something more useful, like install our code and then lint it. So what I'm going to do is I'm going to look at another project where I had this set up, and I'll just copy one of those commands. So let's see. I think I had like something in my repo called PyTest GitHub Actions. Here we go. And I'm going to look at this one just like this, and this looks like a good one to use. And I'll put this in here and then show you what this does. So what this does is if I do a git pull, I can pull down those GitHub Actions because they're just a YAML file, and then I could edit it right inside of my project. Here we go. Here's my main file. And let's just throw this in there. Let's just throw this in there. Now, and then let's just walk through step by step what this does. So this is a YAML file that GitHub Actions will run, and what it's going to do is it's going to build it on every single push. So it doesn't matter if it's a master branch, a staging branch, every branch, it'll go through and build it. In fact, maybe I'll just make this a little bit cleaner. It's going to run it on whatever the latest version of Ubuntu is. It's also going to run it with Python 3.8. And then I just tell it what commands I want it to run. So for now, I only have a install and a test. So I'll just remove these steps for now, and we'll get this working first. So go through here, and we've got make install and then make test. So let's go ahead and check that in. So I'm going to go through here and say get status, make these changes, get add.github. There we go. And from here, we'll say adding main.yaml file. There we go. Push. Okay. Now if I go back to my environment and I say Devops by test, it will again be running. There we go, adding main.yaml file. And what's nice about this again is I can actually just look at the output and just see this thing running. And it does what a coworker would do, right? So this is, let's say I have a coworker, an intern, or a new hire or something. Why would I make them the guinea pig when I could do the build server that tests all this stuff for them, so that later when they check out my project, everything works, right? So what did it do? First, it set up Python 3.8, then installed the code. It did the make install command. It then ran, it actually ran PyTest, not PyLint. So I can just fix it so the names are the same. You can see I said lint with PyLint. I'm going to say test with PyTest. There we go. And this, it doesn't change anything. It's just the description. Test with PyTest. There we go. How do you spell PyTest? PyTest like this? Or no, I think it's like PyTest. There we go. I'll go through here and make that change, get status, right, get add. Okay, adding PyTest. There we go. So now that this is pushed, what we can do is check again and make sure that this is working. Notice as well, like this thing will show you when it's passing. I go back to actions, and again, we didn't change anything other than the description of the command. So this is going to go through here. It's going to build it. There we go. And you can see test with PyTest. I made the name. Now, what's awesome about this is that we can build off of this. This is a scaffolding that's set up. It's automatically running. Anybody that checks it out will be able to benefit from the cleaning process that happens. And then what we'll do next is start to make it a little bit more advanced. We'll add some linting, we'll add some maybe a command line tool, test that command line tool. So this is probably a good spot to take, let's say, like a 5-minute break to give everybody some action, so like a little bit of a coffee break for 5 minutes. And then I'll answer any questions that you have, and then we'll build the second part of it, and we'll kind of tweak this and make it a little bit more advanced. So next up, I will do a 5-minute break timer, and then we'll be back in just a second. All right, so let's go back to the Sketchpad here and just see what we're going to do for part 2. So this was part 1. You know, we had a pretty cool setup of, you know, getting GitHub Actions and all that stuff, but now we want to kind of take it to the next level and really build upon what we did before. So what we should do is hook in some other components. So what else could we actually? That's actually a good diagram. Let's just stay with that diagram. So I'm going to go back here. So although now that diagram went away, not a big deal. I'll do another one. The connect this as well. So before we had the basic CI set up with we'll call this GitHub Actions and our code. But now we want to add a little bit extra stuff to it. So we want to add a make lint step. And also we want to add a command line tool, command line interface, and then also I would want to test that tool as well. So we'll want to test that command line tool. And then I want to hook all that into our GitHub Actions pipeline. So that's what we're going to do next here is just add some additional functionality, extend our continuous integration pipeline here with command line tools and GitHub Action pipeline. So to do that, next up, what I will do is go to this cloud environment here and start to add a little bit more detail. So if you remember here, this is kind of a basic script that we could make it a little bit more powerful. And so one of the ways that we can make this more powerful is make it a command line tool. That way I don't have to have this boilerplate code here. So in order to do that, I'm going to import the click library. So I'll type in import click. And what's cool about click is it's really easy to take a function and then turn it into a command line tool. And in fact, I could just write over this function. And so if I remember correctly, I can just grab something I've done before here that's a command line tool. I have a bunch of command line tools. Let's just go to another course I did, like Devops course. There we go. Here's one. And I'll look at, let's see, this looks good. Here's a command line tool. So really you can see here that the main things that you need to do are something like this. You just put command and option. So I'm going to throw that at the top and use this as a way to kind of scaffold it out. So I'm going to say I need this. So I need like a under name method. And what this does is it's just really boilerplate code that allows you to run a function as a script. And so I think we called this thing Marco. So I'll need to run Marco, right? That's it. That looks good. And what is this? What is this option here? This just tells the lint command, which I'm going to set up in a second, to ignore the fact that I'm using this fancy framework. The other thing I'll need to do is I'll just kind of remove this. And then you'll see that it's pretty easy to make a command line tool with click. Is you put @click command, and then all I need is one option in this case, which is I need to make an option that allows me to take in a name and then key on it. So we'll go through here and we'll say name, and then we will select in the name here like this. So we'll just say name, and notice that the name is the -- name has to be the same as the name that's passed into this function. So really we're talking 5 lines of code, and I've got a command line tool, and let's test it out. So if I type in Python hello, it doesn't do anything yet. So what I'm going to do is I'm going to do -- hello or -- help. Notice it tells me what it is that my command does. And in fact, I can now use it. So I can go Python hello and then do -- name, and we'll put in Marco. And in this case, notice that it doesn't print anything out because I need to have a message come back. And so what I'll do, instead of having to do a return, I'm going to change it to a print so that it'll print it out. So let's go ahead and change this, and we'll say click.echo, and I'll put in just this word polo like that. And then for the return, I'll also do click.echo no match. Right, so all this does is it tells the click command line tool to echo out this statement. There we go. Let's go through here. There we go. So in this particular statement, though, we want to say else, right? So we want to say if I pass in the word Marco, return click out polo, otherwise I want you to do no match. So if I do it again, there we go, we've got polo. So we've got something cooking here. I'm going to check this in. So we'll go get status, get add hello. Now a couple things to remember here is that this will in fact break our code because of the fact that I've tweaked a little bit the way this function works. So I guess I have a couple of options here. Is I could either keep the original function and then change the test, or I can change the test to reflect this new piece of code. There's no perfect answer here, but what I'm going to do is I'm going to change the test. So I'm going to type in, so for example, if I do make test here, it'll break. There we go. It completely blew up. Now, the way to fix this would be I would use, instead of this regular PyTest test, I'm going to use a fancy click test. And so I'm going to go back again to my other project here and look at the way I did this before. So I'll just, again, kind of grab some boilerplate code and do this. And let's just throw this inside of here. Put this, actually, let's grab this code here. Go like this. And so what I'm going to do is I'm going to just copy this other test that I had earlier and just tweak it a little bit. So if I go to this import, you can see I say from click.testing import CLI runner. What this does is it allows me to use Click's command line tool framework to test this command line tool. So it's still going to be tested by PyTest, but it's going to use the Click test runner. Next, I'll need to change this so that it says hello like this. And then from there, I'll import Marco. From hello, import Marco. Perfect. Now I'll just change this to call this test Marco, right? That looks good. I made an instance of the runner. And then all this is pretty easy to understand. What it does is it invokes the command line tool for me inside of this test. So next up, what I'm going to do is that I'm going to put in this -s name. And then I'm going to put in the word Marco, like that. And then I'm going to assert that Polo is in the output, right? So run that tool that I just created, invoke it. Now notice that this isn't going to be search, it's going to be the word Marco, right? So invoke that command line tool, pass in the word Marco, assert that it comes back without an error. That's what the result.exit code 0 is, and assert that the word Polo appears inside of there. Okay, does this work? Let's go ahead and do make test. There you go, everything works. So this is a really awesome way to build command line tools. Is first build a function, gonna get the function working, then decide either you use the function as is or tweak it a little bit, and then put some parameters on top. So now now that I got that cooking, I'm gonna again go to get status. I'm gonna check both those in and double check that the build server remotely is able to run all that code. So we'll go through here and we'll say get add hello.py, get add test hello, and we'll say commit and say adding test code. There we go. All right, perfect. So next up, what we're going to do is that I'm going to go to this environment here, which is Devops PyTest, and I will say, if we go to Actions, and I look at it, I should be able to look at the output of the build server, and you can see a setup job, run action, set up Python 3.8, install dependencies, test with PyTest. We can even look at the output of the test run. Here we go. I look at it. Awesome. I've got a whole test that runs a command line tool, and everything's working the way I would expect. And you can see that even shows me that there's partial test coverage because I added additional logic into my code. So this is really, really powerful in that I've already got like kind of an application building, but we can do more. The next thing that I'm going to do is that I'm also going to lint my code as well. And so again, I'll just kind of look at an older project here and grab a lint example from a Makefile and just kind of copy this right here, just add this step, and then we'll make it a little bit fancier, right? So what I'll do in this Makefile example is do this. We'll say make lint, and I'll notice a couple things that I do here. So when I use pylint, I disable two of the options, which are R and C, which I think are recommendations and configuration. I find those to be really not actually helpful, and so I just always disable those. And then the only other thing I need to do is put the name of the command line of the file itself that I want to lint. So I'm going to type in hello.py, just like that. And then again, you don't want to have to remember all these flags and all this stuff. It's just irritating. So what I'm going to do is I'm going to type in make lint. There you go, make lints. Perfect. Now, in this particular example here, we are going to next up do git status, and we see that the linting works as well. But remember that if we want the build server to also run those same operations, I'm going to have to add another step, right? So what I'm going to do is just copy this section here and add that make lint step. There we go. And we can go here and this, and we can say lint with pylint. Lint with pylint. There we go. Make lint. And there we go. I've got a lint. Perfect. Now that I've got that working, I also have the lints inside of the GitHub Actions. I can go through and I can just check this in. So we'll say git add.github workflows main.yaml git add makefile adding a lint step. Perfect. Okay, so once this is cooking, then again I can go back to my GitHub Actions and make sure that the build server's checking all my code. Okay, let's go through here and let's go to Actions. Sorry, wrong project. Let's go to this project and let's make sure the Actions is running. There we go. Adding the lint step. We can look at the output. We can see that it sets up the code, it installs the dependencies. It's now doing the test with PyTest. And additionally, we also are successfully able to pass lint. So you may be asking yourself, if you don't have experience with PyLint, like, wait, what does this do again? Why do I care about this? Okay, let me show you why you care about it and why it's super helpful. Let's go back to our project. And let's go to the command line tool here and let's mess it up a little bit. So like, let's say, for example, you accidentally put something weird inside of here that was difficult to debug, that it was an error. Like, for example, I think it will blow up. Well, for sure it'll blow up with this. Let's just make an empty variable and kind of make a syntax error. Now, test would mostly catch this as well, but the lint will catch it too. So if I type in make lint, you can see here that it actually tells me that on line 3, there was a syntax error at character 5. There we go, 1, 2, 3, 4, 5. So it exactly tells me what the problem is in my code. So it's really handy to have that kind of error checking built into my project so that I don't accidentally, like somebody distracts me, I'm getting called somewhere and I get, pulled in. I can go through and immediately, fix the problem. So what I'm going to do as well, I'm going to show you, I'm going to swap the order here. So I'm going to go like this, and this is a pipeline that goes step by step, right? So it goes make install, make test, make lint. I'm going to swap the order and say, I want it to do make install and then make lint and then make test. So let's go ahead and swap that order, go back here, do this, and we will go through and do a lint operation as well. And so now, or I'm sorry, we'll do the lint first. So now that I do lint first, if I type in make lint, it should still work, but remotely it'll first fail on that. And so I want to check in intentionally this broken code to just double check that the build server is going to catch it and that it will fail on the lint step, which will give me a bunch of great output, right? Which is what I want. It's nice to fail on the test step as well if you're testing it, if you're trying to make sure that the tests work. But the lint in a way is a good place to start with because it gives you such verbose feedback about where there are errors in your code. So I'm going to check this in. So go through here and I'll say git add.github And then I'm going to say git add hello, adding hello. Here we go. Okay, next up, what we'll do is go to PyTest, and I will go again to the actions, look at this output, and this will fail if the lint is doing its job, and exactly it fails where I would expect it to fail. And notice as well that it shows you what it didn't get to, right? It didn't get to the PyTest step. And so this is actually pretty helpful, because now a coworker or me or whatever, we could look at this and we could diagnose it. And look, here we go. It even tells us exactly where the error is. It says invalid syntax on line 3, character 5. This is a problem. We need to fix it. So now I just go back to my project and fix it. So if I go back to this Pylint project here, this is a good example of how you can now debug the problem and fix it based on the output from GitHub Actions. So I'm going to next go to my hello file and comment that out so that we see that the error has been fixed. I'll also do this. I'll say make lint, and you notice that now it works. Now we're about in a good time to make things a little more advanced here. And what I could do with this Makefile is I could say all, and at least locally, I don't think it's good to do this in the build server because I want to see each step. But in this situation, it's a little lazier. I can just do this. I can say install lint test, and maybe even if I want to swap the order around so I don't get confused about which is the sequence, I can kind of swap it in here too. So we say install lint test, right? And so if I type in an all, it'll just run them all. So this is something that typically is a great way to even automate the automation. So if I type in make all, wait a second here. So no rule needed, install lint tests. Not sure why that thing is giving me an error here, but let's do it again one more time. Make all. No rule to make install. Yeah, anyway, it's a minor. I don't know why that's not working, but there's probably some kind of a spacing error I have in my Makefile. But the main takeaway is that you could do make install, and then after you do make install, you do make lint. After you do the make lint step, then you do make test, and all of those steps should work, right? So now that I've got that working, let's go ahead and check the code in. So let's say git status, git add Makefile, git add hello, and then check in this fix, fixing the lint. Git push. Okay, so we're in a great spot here to kind of get things cooking, and in particular, the next step for us would be to kind of go through and add some additional things that make our project better. So one of the ones that I like to do that really starts to make my project even better is there's a tool called Black. And if I type in the word Black, here we go, and I type in make install, we'll go through here and do make install, just like that. What this will do is it will install this formatting tool that will format all my code for me. So if I go through here and I type in hello, just like this, or I see hello, I can now use this to format the code and make it a little bit automatically format it for me. So if I go through here and I type in Black, there we go. and then I put in the word hello. There we go. It just it literally rewrites the code and makes it a little bit cleaner. It's like, great. There we go. Thanks Python Black. So from here, I could even do a get diff, and you can see what it looks like. Get diff hello. Right, you can see that it just changed the single quotes to double quotes, and changed the if under name to have double quotes, and so just kind of clean things up a little bit here. So and then put a space between the comment. Okay, so now that I've got that working, what I'm going to do is I'm also going to add that into the Makefile. So I'll type in black here. But I'll do it in the order that I would like to also run it in the build server, because why not? Why not have a step that just double checks that the code is not going to have a formatting error, and I can do that first. It's like the first safety check would be, does the code format okay? Okay, great. Does the linting work? Okay, great. Does the testing work? Okay, great. So let's go ahead and do that. Next, we can say format. And then I can type in the word black and then hello, just like that. Great. So we've got this cooking here. We've got our code formatting. Also go back to the YAML file, and I'll also do the same thing. I'll just say, let's add a step here that allows us to just check the formatting to make sure things are going correctly. Because I can always look at it as well if I needed to check that formatting change in. At least it's showing me that it made a formatting change, and I can later fix it. So we'll go ahead and we'll say format with Python Black. Here we go. Format code with Python Black. Let's see, make format, just like that. Okay, perfect. Let's go through and do make format. Let's go here and make format. Perfect. That works. That's exactly what it's going to run in the build server. And notice when it's already been formatted successfully, it'll say one file left unchanged. So I can always look at that inside of my build process and kind of just double check that my code is being formatted correctly as well. So we'll go ahead and say get status. And again, we changed the Makefile, the hello file, the requirements, and we changed the GitHub Actions. So we'll say get add dot get GitHub workflows, and then we'll say get add Makefile, get add hello, and then get add requirements. There we go. And we'll commit this, adding requirements. .txt. Perfect. Okay, let's go ahead and push it. Perfect. Now that I've gone through and I've pushed that change, I'm going to go back again to this file and go to GitHub Actions. And from here, I can select build and check the set up the job, install dependencies, format code with Python Black, lint my code, test my code, right? So we got a lot of stuff, really powerful stuff cooking here inside of this project. So now that I've got this, what I could do is again, if you're following along here, you can actually just literally fork this project. And let me just throw this into the chat. Like I'll say, feel free to check out this project, like that. There we go. And so from here, really we're in a pretty good spot. And I guess I could answer a couple questions. So one question is which I think I used, which was let's kind of go through some of these right now. Let's see. We've got push this to slide area. One question is, what is uses action checkout to? Let's go ahead and take a look at that. This is, I believe all this does is it must be something internal to GitHub Actions. It must be like it must be like how they do operations, and I don't know exactly what would happen if you said checkout via version 1. I'm assuming though it's like they must have like a way that they execute GitHub Actions commands, and that's just their boilerplate. It's a good question. I don't know off the top of my head. The other question I saw was somebody asked about doing formatting all of your code. So if you wanted to format all of your code in your project, you could, I believe with black, you can do this. You can do black *.py, and I believe it'll format multiple files, right? So you could just do an asterisk. So if you wanted to, you could also do this. You could just say, in your Makefile, you could just say *.py, just like that. And now notice that the test file, they just kind of cleaned it up a little bit with that tool. So if I just said git status, I could say git add Makefile, git add test file, like that. Go ahead and commit this, adding in test code, changes to black, and now we're able to get all this cooking. So again, if I go back to my GitHub Actions here, we can just double check that all this is working. So actually, wrong project. I'm going to close that project. It keeps confusing me. So if I go back to this GitHub Actions, you can see, here we go. The setup Python 3.8, install dependencies, format code. All these steps are working properly, and additionally, when I look at this Python black command here, you can see that all of the code inside of here has been able to be successfully formatted using the Python black tool. So really, we've got a pretty good setup here. This is, I would say, a high quality professional version of doing continuous integration. The only piece that we're missing would be if we wanted to deploy the code somewhere automatically, how would we do that? And so let me just shift gears here to a slightly different project. And I'm going to show you, I have a Flask machine learning service app that I don't know if we have time to get too much into it, but I'll show you some of this. So basically this app right here, the way it works is that just like we did earlier, there's a GitHub project. A change event is triggered. In this case, though, instead of me using the GitHub Actions framework, what I do is I use Azure Pipelines. And what Azure Pipelines does is it is a cloud-native build server. And the cloud-native build server will enable a deployment to a serverless environment, which is Azure App Service. From here, what will happen is that there will be a Flask machine learning application that's running and will constantly be doing updates to it. So this is a process called machine learning operations, or another way of describing this would be continuous delivery of a machine learning application. And it's not that much more difficult than what we already did. And if you wanted to play around with this yourself, this would be a good project to play around with. But in a nutshell, the way it works is that this particular application has some Flask code that allows us to do predictions, and then I can actually run this thing locally. So why don't I in fact kind of start to play around with this inside of Azure? So I'm going to go here and kind of see how this would work. So I'm going to go back to my Azure environment here, and I think I might even have this checked out in this particular shell, and I can show you some of the tricks here. So first up, let me just see. Do I have this thing running? Yes, I do. So here's Flask ML Azure serverless. The way that the serverless operations work in the cloud is that they take a Flask application, like in the case of Google App Engine or Azure, and they literally, from the environment you're in or the directory you're in, it just throws that into the cloud somewhere and lets you deploy it and then do a prediction to it, which is pretty cool. So in this case, before we get there though, let me just show you how you would run it locally. So I'm going to first source a virtual environment. So I'm going to say source // dot. There we go. Flask ML Azure, bin activate. Now I'm going to say Python app.py, just like this. And I'm going to run it locally. What's awesome about running it locally is that that this will show me that this thing's working in an environment that I can test with it, and I can even play around with it inside of a cloud shell. So if I went through here and I said this icon, which is web preview, I can configure it to port 5000, which you see right there. Let's go through here and say, I don't know why that's acting weird, but let's try this. Close this editor. Yeah, for some reason that is not wanting to open up, which I don't know why it's not wanting to open up, but in a nutshell, the main takeaway is that you can preview here. That's the least important thing I was going to show you. So once we know that this is working though, Azure has some commands that will automatically deploy this app. So if I type in AZ, in fact, I think I can just go to history. I just find one of these commands that I did. There we go, AZ web app up. If I run this, I believe this will wake it back up again. So let's go ahead and try this out. We'll see AZ web app up. It tells me that this service already exists, and this command will deploy the contents to the existing application. So what's going to happen is that it's going to look inside of this directory, and it's going to zip it up, and it's going to throw it up into production somewhere. So that might take a few minutes. So I'll just kind of let this thing, run here. But essentially, that step that I'm showing you right here is the piece that we would want to set up after we do continuous integration. So let's just draw that out about how that would work. So if I wanted to take all the concepts that we went over and hook those all up, it would look like this. It would be step one would be, create this continuous integration environment, right? So this is the CI environment. Once you've got that working, all the tests pass, everything like that, the final step to get this to be a production machine learning environment is that we're going to go through and ML app. we're going to go through and build this out to deploy itself automatically, and it's going to be, again, very similar to what I just showed on the command line. Is we need a cloud native build server. Native build server. And this cloud native build server will after the testing has passed, right? So we'll go through here. So we'll say after testing. We will deploy that to this cloud-based environment so that we can do a prediction against it. And so the way we would set that up, at least on Azure, every cloud has their own cloud native build server. Azure's is called Azure Pipelines. is you would tell Azure Pipelines to kind of take over, and it's like a more heavyweight type build server than GitHub Actions. So let's go ahead and take a look at how you would do that. So we would, if we go back to Azure, it might have already deployed. Okay, so look, we can see this code in particular is already deployed. So if I click on it, I can actually run this, go through here, and you can see that it's actually been deployed. It says it's been stopped. Okay, so I can start it. And if I want to go to start, I can go to App Services. And I think I did stop this earlier, and I'll just start it again. So I believe it is, we can just check the IDs here and see which one this is. This is, I believe this is the application. Flask ML service. So it's going to be, I think it's the other one. App Services. This one. So I'm going to click on this one, and I'm going to say start. Yes, I want to start this. There we go. And now I think this would be trivial to run. I think it should take a second and it'll just spin back up. But anyway, however long that takes to spin back up, let me now go to the thing that's going to do the automated deployment, which would be the Azure Pipeline. So I go to Azure Pipelines. Azure DevOps. They call it Azure DevOps Organizations. And then from here, I'm going to go to my Azure DevOps Organization. I'm going to log in. And from here, I can go, I believe, to my account, which is under here. Actually, let me see here. I think I'm under. I think I might have logged in under a different Azure DevOps environment. Let's go ahead and take a look at this one. It's a little bit more complicated than it needs to be, unfortunately. Let me sign in again here. Let's switch accounts. This is the part of Azure that's less fun is, here we go. Let's go to this one and we'll log in here. So basically what happens is that these really heavyweight cloud native environments can listen to the background process, and you can hook it up into GitHub. So if I said new project and I said, I don't know, deploy Flask automatically, it would allow us to create a new project, and then it'll prompt you through where do you want this project to be. So you go to pipelines, and you would click on pipelines, create a pipeline, and then it'll basically ask you where the source is. In this case, we'll say, GitHub, and then I would go through and find my GitHub project. Let's pretend that this is the one that I'm actually working on. In this case, you would go through it. It would try to do some kind of smarts and try to figure out if it could help you exactly how to help you. But you also can do this, which is the Python to Linux, subscription, and you could pick some kind of application, validate and config, and it would go through here and give you all the steps. In this case, forget about the error messages. It would look something like that. Now, if I go back to this particular project here, it'll build out something that looks like this, which is a YAML file that's kind of similar to the YAML file that you would get from GitHub Actions. The main difference is that, look, you could see that it would talk to the application service this time, and it would do similar things, right? So really, if you look at something like GitHub Actions and you look at Azure Pipelines, they're kind of the same thing, except for the Azure piece has all these hooks set up that directly integrate you into this environment for Azure. So that's really, in a nutshell, what happens with the cloud-based environments. And so it might be worth just talking about this really briefly. Is what is it that you get? What are the trade-offs in build servers for continuous delivery? So with continuous delivery, you have a few options here. So now, one thing that you'll notice is that you do have to have the process of IAC set up. So what is IAC? It stands for Infrastructure as Code. And what Infrastructure as Code is it's that stuff that I was just showing you, right? It's, if we go back to the GitHub project, it's this stuff. That's literally Infrastructure as Code, because it will take and configure our project and push it into an environment to deploy it. So you need Infrastructure as Code, and then you have to make a decision about, do you want to do, simple? Do you want to do a medium-based continuous delivery process, or do you want to have a complex-based continuous delivery process? Here we go. Here's the gradient here. So we have simple here, we have complex here, and so here's the simple one would be something like GitHub Actions. And what's nice about it, and you saw this earlier, is that GitHub Actions allows you to do very easy deploys, right? You just go through and you kind of have this like wizardy thing. The medium complexity would be when you get into things like the cloud native tool. So in the case of Azure, they would have these deep integrations, like it would have Azure pipelines. In the case of AWS, they would have the code pipeline. There we go. So we see code pipeline. And then in the case of GCP, we would have Google Cloud Platform. There we go. Google Cloud Platform. And the idea here is that these kind of medium level build servers, they have a pretty deep integration, so it's a reasonably smooth process, but it's kind of hooked into the way that this particular environment runs. So you can see in some cases there's actually some hidden complexity. Now, if we go to a slightly more complex but flexible, and we could say like maybe this would be rigidity versus flexibility. It kind of goes on top of here, right? Which is rigidity versus flexibility. And so in a way, because it's simple, it's going to be more rigid. And then if it's more complex, it'll be more flexible. These cloud native ones have some sweet spots, but in terms of the flexibility, another option that you could pick would be something like Jenkins. And so what Jenkins does is it also allows you to go through here and build out a cloud-based environment. So let me actually just show you really quick here. One of the things that you can do with Jenkins that's pretty cool is that if you wanted to play around with this on your own, we don't have time to get into it right now, but you can actually, inside of the cloud environment, just download a jar file and just run Jenkins locally. And so let me just show you how you could also play around with yet another build server and to see which one you want to use. So what I'm going to do next is I'm going to go to Jenkins, and I think there's a Jenkins war file download. We'll just type in Jenkins war file. Let's see here. There we go. We'll click on that. And I'm going to just cd. No, we'll do it right here. We'll just say wget, and I'll download that war file. And then I can look at the instructions, which are right here. Jenkins Java war. Perfect. And in this case, it says that the Java is too old, so we can just do a yum install Java 8 maybe, sudo, or yum upgrade Java. Let's just do that. Yum upgrade Java. Let's actually see what it says here for Java. It might give us a hint. So we might need a slightly newer version of Java in this particular environment. Does it give us a Java command here? Installation of Java, here we go. So we can say Fedora. Which version of Java do we want to do here? I think it would be OpenJDK 8. Let's try that. If this doesn't work, it's not that big of a deal. This was more of like a nice to have. Yum or sudo yum install OpenJDK. Does that work? Nope. Let's see. I might have one more try here at getting this version of Java installed. Let's see here. Java, is it OpenJDK? Let's try that one. Maybe OpenJDK. Huh. Well, anyway, I typically install this on a spot instance and then I shell into it. But without wasting too much time on this, because we don't have a lot of time, you can run Jenkins locally like this. And then you can open up a port, and you could also start to test out a build environment as well locally. And then what then that does is it gives you the ability to kind of test for your environment which of these types of continuous delivery systems do you want to set up. You can do simple, right? GitHub Actions, IAC. You can do medium, Azure, AWS, GCP. Those cloud native systems, or you can do complex and get into Jenkins and fully tweak it yourself. So that's probably a good spot to maybe stop and see if there's any final questions and kind of start to wrap things up. So